All right, following our themes of talking about matter, of talking about states of matter, we've now got properties of matter. And there's a few ways you can categorize some of the properties of matter. So one way to categorize a matter's property is to separate it into physical and chemical properties. So what's the difference? So physical property is any property of matter that doesn't require a chemical change. So this would include a substance's color. It would include its melting temperature or its boiling point. It might include its odor, its density. It might include how hard or soft it is if it's a solid. While a chemical property might describe the way that a substance might react with other substances and change. A perfect example of this might be flammability, which is its ability to burn in the presence of oxygen. Another chemical property might be a substance's pH level, as this only affects a substance when it's in contact with another substance and it loses or gains hydrogen ions. Another way of categorizing properties of matter is into the two groups of intensive properties and extensive properties. So intensive properties are properties that are not dependent on how much of a substance there is. For example, a substance melting point is the same whether you have a small piece of the substance or a big piece of the substance. Likewise, the substance density is also the same whether you have a small amount of the substance or a big amount of the substance. So those are intensive properties, while extensive properties are dependent on how much of a sample you have. So a good example might be mass. The mass of the sample of matter will change depending on how much of it you have. Likewise, its volume is also a property that is dependent on how much of a sample of that matter you have. Now, these physical and chemical properties that we mentioned before, both of them are able to change, but they change in very different ways. Take, for example, something like water, right? If you have water, what are the physical properties of water? It's clear, it's a liquid, and because it's a liquid, that means it's going to have a fixed volume, like we mentioned before, a fixed volume. And it's going to have a changing shape. Right, those are the physical properties of water. But what happens if you heat up water? If you heat up water, it's no longer a clear liquid. It becomes this vapor of gas. Right? This means it doesn't have a fixed volume. This means that it's going to try and fill the space of an entire room. Or what happens if you freeze water? If you make it get really, really cold, what happens then? You get a solid, and it no longer changes its shape. So you got to be careful. Just because the chemical structure stays the same doesn't mean that the physical properties are going to stay the same, especially if the environment changes, like the temperature, the pressure, and so on. Chemical changes, however, change the molecular structure of the substance, right? So there's a change to the molecular structure. And one example of this is fire or combustion. So imagine you have some hydrogen gas, which is just two hydrogen atoms connected together, and they're just floating around because they're a gas. And then you introduce some oxygen molecules and you introduce some heat, maybe a spark. What happens is these bonds break so that all these atoms are separated and you have floating atoms everywhere that want to bind with something else. And you end up with water vapor. That's all fire is. If you burn hydrogen gas, it reacts with oxygen to create water vapor. But you can see here the molecules that we had at the start are not the same molecules that we have at the end. This is different to the physical changes where ice and water and steam, they're all made out of the same molecules. Chemical reaction changes the molecular structure of the substance. So why would you learn about the physical and chemical properties of matter? Well, there's a few good reasons. First of all, it can be used to identify what a substance is. So if you have a substance and it looks very similar to substance A or substance B, and you know that there are some properties that substance A has that substance B does not have, then you can test this substance for those properties. Another reason to learn about properties of matter is so you can separate substances from mixtures or compounds. For example, if you have a mixture of iron filings and gold filings, and you only want the gold filings, you could go picking out these filings one by one and sorting them into two groups by color. Or you can tell yourself, hey, I know that iron has the property of being magnetic. So I can use that to separate the iron from the gold. Another common example is distillation. Say for example, I have water that has salt in it, and I want to separate the water and the salt. I can tell myself, well, I know that a property of water is that it has a boiling point that's fairly low. It has a boiling point of 100 degrees. So what you can do is you can get a flask and you can fill it with the salt water and then heat it up using something like a Bunsen burner, and then cool the water so that water collects into another flask. It's a terrible flask, by the way. While this flask eventually loses all its water and becomes just salt, separating the two. Another example of separating compounds based on their physical properties is filtration. If you have a mixture and you know that some of it's a liquid and some of it is a finely ground solid, you can put it through a paper cone, and all the liquid will drip out while all the fine powdered solids will remain inside the paper cone.